Hi there. We looked today in class at linear inequalities and specifically how to discover or evaluate whether or not a point is a solution to a given linear inequality and how to graph a given linear inequality. Okay, and so these notes are on my website. If you wanted to go on there and print them off and kind of follow along with me, they're also on my website in filled out form if you'd rather just have them printed off for your records and for your future studying. So we started with discussing solutions. An ordered pair is a solution of a linear inequality if the inequality is true when the values of x and y are substituted into the inequality. And so we started with 4 examples here where we just tested that. Determine whether the ordered pair is a solution of the linear inequality. Okay, if it's a solution, when I plug in this point, this x and this y into my inequality, I should get a true statement. And so that's what I'm going to look at. When I plug in my 0 into my x and my 0 into my y, is that statement true? Okay, well, 2 times 0 is 0, minus 3 times 0, which is 0. 0 is greater than or equal to negative 2. That is true. And so yes, this is a solution. Okay, so we're going to do the same thing with each of these. Number 2 here, where we had x is 3 and y is 6. We're going to plug that in. We have 6 is less than or equal to 2/3 times our x, which is 3 plus 4. Okay, we're going to plug in our y equals 6 and our x equals 3. And when you evaluate that, 2/3 times 3 is 2, plus 4 is 6. Is 6 less than or equal to 6? Yep. And so this is a solution. Okay. Next one, we had x equals 2 and y equals 2. So we're going to plug that in. 2 is less than or equal to negative 2 times 2 plus 1. Plugging in x equals 2 and y equals 2. And when we evaluate that, negative 2 times 2 is negative 4, plus 1 is negative 3. Is 2 less than negative 3? Nope. And so this is not a solution. Okay, and then the final one here, we had x equals negative 3, y equals 7. We plug that in, negative 3 into our x's spot, y equals 7. And we evaluate if that's true. Negative 5 times negative 3 is 15, plus 3 times 7, which is 21. 15 plus 21 is 36. Is 36 greater than negative 12? Yep. And so this is a solution. Okay, so that's that first strategy, and that's all you're asked to do, honestly. If you're given a point, you're given an inequality, plug it in. Is it true? Yes, then it's a solution. Is it false? Then it's not a solution. Okay, so then we got into graphing inequalities. Graphing inequalities, I typed up these steps for everyone. It's very similar, honestly, to graphing just a line. Right? In fact, that's going to be our first step. We're going to essentially take the same steps as we usually would to graph the line using whatever form is shown. For example, you would figure out what your m and your b are if it's in slope-intercept form, or you'd figure out your x and y intercepts if it was in standard form. Okay? The last 2 steps are where the inequality changes a little bit from graphing just a line. When you're graphing an inequality, you're going to connect the points with a dotted or a dashed, if you prefer dashed, a dashed line, if the symbol is just greater than or just less than. Okay, a solid line, you're going to connect it with a solid line if the symbol is less than or equal to or greater than or equal to. Right? The reason we change the line is to indicate whether or not the points that actually lie on the line are still solutions of our inequality. Okay, a point that lies on the line itself would be an equal to point. Well, here with our less than and greater than signs, there's no equal to component. And so we can't do a solid line because we can't actually include those points. Those points would be equal. These inequalities don't include an equal. And so you can't color it in. You can't make it solid. You have to do kind of a shadow effect, a dashed line. Okay, here there's an equal to. And so we connect it with a solid line saying that we can include those points. They are also solutions to our inequality. Okay, and so then the final step is you're gonna test a point on one side of the line, and which point you choose doesn't matter. I usually go for 0, 0 as long as it's not on the line. That's an easy one to plug in. And you're gonna take that point, whatever one you want to pick, and you're gonna plug it into the inequality, and you're gonna see what statement you get. If the point is a solution, if you get a true statement when you plug it in, you're going to shade the area on that side of the line. If the point is not a solution, if you get a false statement, you're going to shade the area on the other side of the line. Okay, and that's how you graph an inequality. So we're going to look at a few here. Okay, example 1, let's start here. We have y is greater than 3/4 x minus 2. Okay, you always want to make sure you take a moment and take note. Is this going to be a dashed line or a solid line? Well, because this does not have an equal to, this is going to be a dashed line when we connect it. Right? Okay, which will come after we graph. This is in slope-intercept form. So I know my b. My b is -2, so that's where I'm going to start. It's my y-intercept down here at -2. My slope is 3/4. My m is 3/4. Which means I'm going to be going up 3, because it's positive, and then right 4. And so that's what I'm going to do. Starting here, I'm going to go up 3, 1, 2, 3, right 4. Up 3, 1, 2, 3, right 4. And I'm going to connect those points. We did all of those exact same steps when we were learning to graph in slope-intercept form. Okay, but when we connect the points, remember, it's going to be a dashed line. So here we go, got our line, and we're going to dash that line. Now you want to make sure you're very clear to make it a dashed line. If you accidentally make it a solid line, that's an issue, especially if those points are close together. Make sure it's really clear that you're making it dashed. Okay? Okay, so here's the final step. You've graphed it like we already learned back in Unit 3. You do a dashed line because it's not equal to. So our last step is to pick a point, make sure it's not on the line. 0, 0, which is our origin here, isn't on the line. That's usually the one I go for. So I'm going to plug in 0, 0 into my original equation here. And I'm going to see, does it make this, I'm sorry, my original inequality, does it make this inequality true? When I put in x equals 0 and y equals 0, I get 0 is greater than 3/4 times 0 minus 2. So I plugged in 0 into both spots. And 3/4 times 0 is 0, minus 2 is -2. Is that true? 0 greater than -2? Yes, it is. And so since it is true, since it is a solution, I'm going to shade that side of the line, the side of the line that has that point on it. Sorry, 1 second. There's an announcement going on. We're going to be going on to example 2 after this. Okay, sorry.
In a leadership position for Interact Club, there is a meeting in room 802 right now.
Okay, our second problem here is 2x minus 4y is greater than or equal to 8. Okay, this is in standard form, so standard form we find our x and y intercepts. My y-intercept in this case, if I make my x's 0, which is the definition of a y-intercept, if I divide that -4 over, I get 8 divided by -4, which is -2. So my y-intercept is -2. My x-intercept, if I make y 0, I get 2x and 8. If I divide that 2 over, I get 8 divided by 2, which is 4. And so my x is 4. Okay, just like we learned back in Unit 3 when we learned to graph standard form. Okay, so now that we've got those points, we're going to connect these points Since this is greater than or equal to, we're going to be connecting them with a solid line because we have equal to in there. And then we are going to test a point, not on the line. Okay, so again, I noticed the origin is not on the line, so I'm going to go ahead and test 0, 0. I'm going to put in 0, put in 0. You get 2 times 0 minus 4 times 0 is greater than or equal to 8. 2 times 0 is 0, minus 4 times 0, which is 0. 0 minus 0 is 0. Is 0 greater than or equal to 8? Nope. And so since 0, 0 here, the origin is not a solution, I'm going to shade the other side of the line, indicating that all of these points over here are solutions, and that these points on the other side are not. Okay, so then we're on to example 3 here. Example 3, we have x minus 4y is less than or equal to 0. This one initially looks like it's a standard form one. It is, in fact, in standard form, but we can't graph it, unfortunately, with x and y intercepts. Because when I cover this up and I get my y-intercept, I get 0, which is the origin. And when I cover up my y to find my x-intercept, I get 0 again, which is the same point. You have to have 2 points to connect to make the line. And so we are going to need to manipulate this one to get it into slope-intercept form. Okay? Okay, so you could do this however you want. Some people like to subtract the x over, other people prefer to add the 4y over. Again, it's whatever your mind sees. I typically opt for adding the y over, just because then things are positive, and I typically like positive numbers. 0 plus 4y is 4y. But it's not quite in slope-intercept form. We do need to get rid of this integer here, and so we're going to divide that 4 over to the other side. And so we're going to get 1/4 x is less than or equal to y. 1/4 x is less than or equal to y. Okay, so now that that's the case, we can figure out our y-intercept, which is going to be the 0, which is right here. We already plotted that. And my slope is 1/4. Since it's positive, I'm going up 1 and over 4. So I'm going to go up 1 and over 4. Connecting it, it's not equal to, it's just less than, and so it's going to be a dashed line. Okay. And then we're going to test a point. Unfortunately, in this one, we can't test 0, 0. We need to test a different one because 0, 0 is actually on that line this time. So pick, again, an easy one that you think looks friendly, and you can pick any point you want. I like 1, 1 as another possible one. Again, it's your choice. I'm going to go ahead and pick 1, 1. And I'm going to be plugging it into my inequality up here. 1 minus 4 times 1 less than 0. So 1 minus 4 times 1 less than 0. Well, 1 minus 4 times 1 is 4. 1 minus 4 is negative 3. Okay, is negative 3 less than 0? It is. And so the side that has 1, 1 on it, there's 1, 1 right here. I'm going to shade that side saying that yes, those are solutions. Those give me true statements. Okay. Okay, so those are kind of your typical, and I prepared a lot in case we needed to do extra ones, and then I put them all on my website in answer form. So if you were wanting to practice a couple more, you could try maybe the next few on your own, and then you could check them against the notes that I've uploaded, because I did put my answer key up, and so that would give you an evaluation of whether or not you were understanding it. Okay, and they're just sources for extra practice. If not today, if later on, as we get closer to the test, you go, wow, you know, I really should practice a couple more of these, you can pull these notes out again, and you can do a couple more. Okay? I do want to make sure that we've looked at a couple special cases here. there are 4 that I put on, examples 7, 8, 9, and 10. So we'll do 7 and 8 right now, and then 9 and 10 again can be used as extra practice if you would like. Okay, example 7, we have x is less than -5. Okay, we talked about these as well in a prior unit, what this looks like, right? X equals -5. And I know this isn't equals, but we're going to draw on what we already know. X equals -5 is a vertical line. It goes up and down. The reason why is, where does x equal -5? X equals -5 right there. And if I drew a line in through that point, it would be a vertical line right there. Right? It goes through the x-axis. This equation says we're cutting x at -5. Okay, in this case it's going to be a dashed line because there's no equals to in that inequality. Okay, and then we are going to test a point that's not on the line. I still like 0, 0. That's not on the line. So that's what I'm going to test. And in this case, there's no y to plug into. There's only an x. So we're only putting in that point, that 0. And the question is 0, when I plug it in, is that true? 0 less than -5? And the answer is it's not. And so I'm going to shade the other side of that line, the one that doesn't include 0, 0, because none of these can be solutions. They give me false statements. These are my solutions. If I plugged in any of these points, I'd get a true one. Okay, and then number 8, we had y is less than or equal to 2. Okay, the y line is a horizontal line because y equals 2 right here, and we're going to cut through that y-axis. So it's going to be a horizontal line side to side. Because this is an equal to inequality, this is going to be a solid line. Okay. And then we're going to test. Again, 0, 0 is not on the line, so that's what I'm going to pick. And if I plug in this case, only the y, because there's no x value, if I put in 0, is that true? Is 0 less than or equal to 2? The answer is it is, and so I'm going to shade the side of the line that has that 0, 0 on it. Okay. Okay, so that's graphing inequalities, and again there's a number more here that you could try if you were wanting extra practice, or you could bring in and work with me one-on-one, or you could take into lab if you preferred that, or whatever the case may be. I wanted to make sure you had plenty of extra practice if you felt like you needed it. Okay. The last ones we ended with here are writing a linear inequality, and we're going to do 2 here on this video. Okay, writing a linear inequality is very similar to writing an equation. Right? You're still going to figure out what your b is, still going to figure out what your m is. The only thing that's going to change is our sign. We have to determine, is it a greater than, a less than, a greater than or equal to, or a less than or equal to. Okay? Okay, so with this example number 1, my b in this case, where I touch my y-axis, is that 3. And so in my y mx plus b form, which is equals if it's an equation or some sort of inequality that we have to determine if it's an inequality, okay? But y mx plus b, this b is going to be 3. Okay? My m is found by connecting 2 points and finding my rise and my run. So I'm going to go ahead and connect these 2 points. And when I do that, I see that my rise, I went down 3. So my rise is -3. And my run is over 1. And remember, with slope, you always want to go left to right, just like reading a book. So we're going down 3, -3, run of 1. So my slope here is -3 over 1, or just -3 if you prefer it that way. Okay. So all of that's exactly like that prior unit, Unit 3 that we did, where we looked at writing equations. This is the only new piece now of this unit, which is what's my sign? And that's where my solutions are going to come in. All of these points over here are solutions. They're in my shaded region. And so I can use any of those points to determine what my sign is. So for this one, I might pick like 4, 0, for example, that point. I know 4, 0 should be a true statement because it's a solution. If it's in the shaded region, it's got to be true. Okay, so I'm going to go ahead and plug in, this is 4, 0. I'm going to plug that in, my x and my y. So 0 for my y, 4 for my x. And I get negative 3 times 4, which is 12, plus 3. Sorry, negative 3 times 4, which is negative 12, plus 3, which is negative 9. Okay, so what would make this true? 0 and negative 9. Well, this would have to be greater than, and so now we have to ask ourselves, is it just greater than, or is it greater than or equal to? Well, my line is a solid line, and so it's got to be or equal to. And so that's going to be my sign in all of these. There's your answer. Okay, so one more of these. Example 2. Again, we're going to have our y equals mx plus b form. My b in this case, my y-intercept, is down here at negative 4. My m, if I connect those 2 points, left to right, I'm going up 4, so a rise of 4 and a run of 2. Up 4 over 2. And since it's up, it's positive, so 4 over 2, which is technically 4 divided by 2 is 2. Okay. And so here's the new piece. What's my sign? So pick a point in that shaded region. Oh look, my favorite point is in that shaded region. 0, 0 should give me a true statement. Because again, if it's in the shaded region, it has to be a solution. When you plug it in, it has to be true. And so I'm going to take this 0, 0, and I'm going to plug it in. 0, 2 times 0 minus 4. Well, 2 times 0 is 0, minus 4 is negative 4. And so what would make that true? It's got to be greater than. So then the next question is it equal to or just greater than? Well, in this case, it's a dashed line. And so in this case, it's just greater than, not equal to, because it's not a solid line. And so there's your answer.